Hello, people. Today we will attempt to solve some problems that you people suggested. This is like 17 of them, and there's 8 more in the thread in the OMC server. So I guess like you can look at these and decide which one we can start with. Like literally anyone just unmute and say. There's probably no one to say anything
The
against.
primes one, 472, 473 till 490.
Sorry.
472, like bottom. Yes, 15.
Okay, does anyone want to do anything else to start off with? Or do we start with problem 15 here?
No, I actually want to see how bad 15 is.
Yeah, okay.
Okay, so start with 15.
Okay, we will begin with 15. Which looks like super weird thing. Okay, so like there's no way the answer is actually that it's possible it's prime, because that would be extremely stupid. So assume like it's supposed to be composite and we can find some number that will divide it. The natural guess is 3, but okay, we can check. 472 plus 473 till 490. How do you calculate this? 15?
You can just subtract 450 from everything and then
Yes, yes. Okay, this is just 1 plus 2 plus whatever. Till, what is this? 29. Yeah. And this is, it's divisible by 3? Huh.
Not this, no.
Isn't this like 29 into 30 by 2?
No,
Yeah, but then it's also 471.
Oh, it's 18. It's 19 here.
Yeah.
That makes so much sense. Okay. So this is 19 times 20 over 2, which 3 does not divide. So it's not divisible by 3, which is unfortunate. Okay, so what else can divide?
Probably like 7 or 13, because they have this property like alternate 3-digit things.
7?
Yeah, but you
Oh,
don't know
because
which one is
1001.
positive, which is negative.
So 1000 is something like 7 into something.
7, 11, 13.
Yeah, 7, 11, 13. Okay, but it is 1001. So like if you let these be x1, x2, you're going to get some alternating thing. Like it'll be nicer if we took some factor of 999. 9 into 111. Maybe we'll, oh, is 111, yes, 111 is divisible by 3. So 27 into 37. Okay, so we know that 3 does not help. So I guess we can look for 37. If not, then 7, 11, 13. Because 7, 11, 13, you'll have to look at this alternating sum. And since you're allowed to place these numbers in any order, you can change that sum. So you can't necessarily ensure it's always divisible by one of those. 37. Okay. How do you find this? 370, 102.
It does make sense though, because like 19 and 20 is like around half of 57. I don't know.
Yeah. But is there a nice way to, okay, let's just add 102. What is 102 mod 37?
111 is 0, so minus 9.
Okay. Oh, wait. So it's minus 9, minus 8, minus 7. And we go on till what? Well, just like this. Okay, so wait, 370. So 381 or 481. And okay, the sum is like symmetric about 481. So it will add up to a multiple of 37. So it's actually divisible by 37.
Wait, how?
Like
You get
481 is
minus 9
divisible by
multiplied by
37.
9.
Yeah.
It's minus 9,
Oh,
minus 8, and
okay.
till plus 9. Okay, yes. So number is always divisible by 37. So it is not prime.
Nice idea.
Wow.
To look for 37.
See, come on, I
37.
told you 19 is halfway. Come on, that was the
Okay,
disadvantage.
yeah, that's true. It was nice of them because you didn't have to actually add for 37.
Also, like you barely look like mod 37 and then 3-digit sums, I guess. So,
Yeah, like why would you look mod 37 in general? In this case, it divides 999, so it
yeah.
works. Yeah. Okay, one problem down. Which is there any other problem people wanted to do?
Also, if mod 37 didn't work, we were basically like
Dead.
nothing could have worked.
If mod 37 didn't work, answer might actually be so prime because I can't
Yeah.
think of any other reason. Okay, so Anurag says try the China TSTNT. I'm assuming you refer to the 10th problem. Okay. Does anyone else want to do 10th problem or something else? Like you can say in the chat or unmute and say. Unmuting will be nicer.
I think it's fine. By the way, is my mic thing fine now?
Yeah, it's louder
Okay.
than normal, but it's fine. Okay, so people want me to do 7 more than. Okay, first we'll do 7 and then check. Huh. Oh no, it's Geo, but we'll see. Hopefully it's not this. We have ABC, Ortho Center H, second center O. Okay, this is going to be a bit weird. So we have points X and we have point Y. And we want to show that AO bisects X. That's weird. Okay, it's the same as showing AH is a symmedian. What are these angles? It'd be very funny if this works out.
So median and triangle AXY?
AX. Yeah, because AO is isogonal to
Yeah,
it, so
yeah.
it'll be the median in that case. Is this 90? Oh, it is 90 minus C. Okay, we're actually done.
What?
Because this is 90 minus B, and so this is also 90 minus B.
Yes.
So like AXH is similar to, what's the order? YAH. So H is like spiral sim center sending XA to AY. So it's
Yeah.
midpoint of symmedian chord, so AH is symmedian. So we're actually done.
Okay.
Okay.
That was just quick.
There
Also,
wasn't much.
Atul, someone has a suggestion on chat.
Let's say someone doesn't know what incenter is. Okay. So the orthocenter is the intersection of altitudes from all three sides. So in this case, these would be perpendicular. And the circumcenter is just the center of the circle passing through points A, B, and C. So there is a famous lemma relating symmedians and medians. So it essentially looks like this. In triangle ABC, if you have midpoint M and you have, this is the symmedian, it is the line such that this angle equals this angle. And if this point is say K, where it intersects the circumcircle of ABC and the midpoint of AK is D, then the famous thing is that a triangle BDA is similar to triangle ADC. The proof of this is because the quadrilateral ABKC is harmonic, because the tangents at B and C concur with AK. The proof of this is because of by drawing the parallelogram and then noticing cyclic quadrilaterals. And so because this is true, you have that because ABKC is harmonic, BD and BC here must be isogonal because D is the midpoint of AK and C is the point such that AK, BC harmonic. So you also know that these angles are equal. And this angle equals this angle. And similarly, you also get that this angle must equal this, which equals this. And so these triangles are actually similar. So we just used that here. We saw that H was such a point because angle HX equals HAY and angle HY equals HAX. So H is the same point satisfying the same similarity. And because there is a unique such point, it must be the midpoint of the symmedian chord and so lies on the symmedian. And since angle OAC equals angle HAB, AH and A are isogonal in angle BAC. So if AH is symmedian, AO will be the median in triangle AXY. Okay. So like any questions about that, or we'll go to the next thing. I will assume we can move on to the next thing.
Yeah.
So which problem now? I'll just keep scrolling through these.
Second.
The second one. Huh, okay. 1 vote for 2, 1 for 5, 1 for 6. 4. This is like
3.
19. There's no 19.
Let's just do second, no? Okay,
second.
is this a better idea to just start from first problem?
Let's just do whatever people want.
Okay.
Like the first thing that gets 2 votes in general, we'll just do. Oh, it's 5. 5 has lots of people. Okay. We'll do 5. Which I agree looks very cool. Okay.
It just looks like you have to find a number for which modulo that thing just works, probably.
Yeah. How?
Mod 11?
Yeah, mod 11 makes sense because also first mod 9 fails because this would be congruent to 2, which is not 0, mod 9. So mod 9 will fail. Mod 11 makes sense. Let's try that. Becomes minus 1 to the 10 to the 10 to the n plus minus 1 10 to the n plus minus 1 to the n
anything
minus 1.
to the power 10 is just 1, right? Or
Yeah,
this will also
these
fail.
are 1. So you just want minus 1 to the n to be minus 1. So if n is odd, then 101 divides it.
101? What? 1 divides.
11
right?
divides it.
Yeah. Oh, 1 divides.
Okay. So that's nice. So we can assume n is even. So we can just like, if n is 2k, then 10 to the 10 to the 100 to the k plus 10 to the 100 to the k plus 100 to the k. Okay, I don't think that helps, but
Many times there's 11 square would work. 101.
11 square?
101.
100. Oh, yes. Okay, yes. In this case, 101 would work. Because, okay, yes, this becomes minus 1 to the even thing. This is minus 1 to the even thing. This is minus 1 to the k minus 1. So, okay, if k is odd, then 101 will divide. Wait, do you just keep repeating this? Because now
I
you
guess
have
We're
so.
making sure that 1001 and then everything is prime, right? To use.
The real question is it going to be 1001 or 4 zeros, 8 zeros like that?
Yeah, I think it's going to be
Only
like
one of them.
1001 or something. Yeah, okay. So we have that n must be divisible by 4. So if we again repeat the same thing, you have, okay, I'm not even going to write the first few things because they're going to be divisible by 10 to the L plus 1 for big enough L. So really the question is, how do you get, okay, so in general, we're just going to look for something of the form 10 to the L plus 1 to divide this. And these two things are just going to end up being plus 1. And this is just a minus 1. So we want to pick it such that 10 to the L plus 1 divides 10 to the N minus 1 or something like that.
Yeah, and like if V2 of n is L, then that just works, right?
V2 of
N.
V2 of N.
Wait, I mean, if n is even, we're just done, right? Because we take
Yeah,
10 to the n
that's
by 2 plus 1.
Wait, if N is
like
even,
if
how
n
are we
is
done?
10 to the n by 2 plus 1, no?
Oh, wait. Oh, yeah. Also, this is not. We'll need some condition.
Yeah.
Yeah. Okay,
Also, I
we'll
think
need.
it is going to be 4080, something like that.
Yeah, makes sense. So in general, you're doing what? 10 to the 2 to the k plus 1? How does, what are we picking k to be?
Wait, let's do it for one more, I guess, like for
Yeah.
1000. It'll, not
Okay, so
1000. It'll be 10 to the 4, I think, then.
yeah, okay, so let's say k equals 2m. Then we know 10, 10. I'll just write 10 to the 4m plus 10 to the 10 to the 4m plus to the m minus 1. Yeah, you will look more this. And then, yeah, this becomes 1, 1 minus 1 minus 1. And it is divisible. But that's only if m is odd. If m is even, then you need to repeat this again.
yeah, so you can just
And
keep
repeats.
on doing this, right?
Yeah, and you'll do this until you reach the V2 of whatever n is.
Yeah,
So in general, what is the claim? 10 to the 2 to the V2 of n plus 1 divides this?
yeah.
Okay, yeah. So for this, we can just write it as 10 to the 2 to the V2 of n times some odd number. So it's just going to be minus 1 to the odd number. So this ends up being minus 1 and minus 1. But in this case, okay, yes, because it's just a power of 2, 2 to the V2 of n will divide 10 to the n for sure, with the extra factor of 2 also. So it is going to be, both of these are going to be 1. Okay, that's a nice problem. Thank you, Agamji. I think you sent this.
This you should put in some like NTP set of yours as an introduction.
Yeah, it is pretty nice. Okay, does that make sense? Or we can 10 to the 2. Yes. Okay. Like, it is nice problem. Like, it's instructive. But yes, everyone has their own opinion. Okay, right. So which problem do we do next?
I think second highest vote for problem second now, right?
Problem?
Second.
Second.
Okay. Second or 12? 12, 16.
So we are
Okay,
never
let's
gonna
just
win.
do 2 first. Pranav, just keep track of the chat or something. Like, just see what number occurs most often, and we'll do it.
Okay.
Triangle ABC. Oh, it's C-centered. C, A, B, I. Reflection of AP over AI. Isn't this just done? You want CP equal, okay. Like, Yeah.
Seems angle chasing.
No, it's not even angle chase, it's just done. If M is midpoint of arc, or minor arc AB, then M
Oh,
is
then
the center of AIB.
yeah.
And so MP equals MQ, but because AQ is reflection of AP over AI by fact 5, since this is the angle bisector over here, we also have that IQ equals IP. So IM is just the perpendicular bisector of PQ. And since it goes through C, CP also equals CQ.
Okay, that was just like brutally fast.
Yeah, it's fairly standard. There's also like this problem on IMO, that 2006 problem 1 or something, where it had a weird angle
Yeah,
condition.
triangle inequality, right?
Yeah, and no, it's
Yeah.
not even triangle inequality. It's just like you have a point P here, show that CP is at least CI or something. Okay, it's not relevant
Yeah,
to this.
Yeah.
Okay.
The next problem, like 15, 15 got two people. Yes.
15. 15. Wait, 15 we did, no?
What is 15?
Is it possible the number is prime?
Oh, right, fine.
Does IQ equals IP imply CQ equals CP? No, it's also possible that BP equals BQ, in which case I could just have been any point in the perpendicular bisector. But in otherwise, yes, IP equals IQ would imply CQ equals CP. Oh, wait, you said, yeah, what you said is just true. Yeah. Look at 12. I see a lot of people voted for 12. Just this problem.
Yeah.
12 looks like that IMO problem, but different.
This looks like very algebra, no? That IMO problem was very
Yeah, that was it.
It's a IMO problem.
2018 5, I think. The
Oh, VP thing?
Yeah, yeah.
don't spoil the problem for people who haven't done it. Like that's the only idea. Problem is my age. Yes, we can do that next.
What is your age? 17, right?
70.
Okay.
That for any epsilon there exists. And somehow, okay, these are bounded. That's somehow relevant. Okay, looking at these ratios, every ratio is bounded. Below by 1 by m and above by m. Let's just write it because why? Because that's the only information that thing gives us. That's for any. Interesting. Oh, we're not given it's increasing or anything. Okay. Fine. So I don't see how to just like find such an n. So we'll assume that for every n there is some like t that's like f of n or something, such that we have that summation ai by ai plus 1 from I equals n all the way till n plus f of n minus 2 or something. Yeah, such that this is always strictly less than t minus epsilon. Okay. But how does this help? Because the summation is pretty weird. Like, okay, because there are t of these here, maybe I should write f of n. Okay, let's just write it as t, because this f of n thing isn't really helping anything. So for every n, there is such a t. AMGM, oh, okay, yeah. So by AMGM, we have that this is at least p times tth root of an by an plus t. Okay, that's interesting. It says that an by an plus t is strictly less than 1 minus epsilon by t. Okay, that seems useful to the t. Oh, that's actually very nice there, because for
It's like e to the epsilon type thing.
yeah, e to the minus epsilon or something. Because okay, for
Yeah,
sufficiently
yeah.
large t, this is this can be treated as almost some constant c. So it's saying that for every n, there is some. So it's saying like for all n, there is some t such that an plus t is greater than an by c or something. Wait, is c is less than 1. Okay. Oh, this kind of finishes, no?
This might not be true as well, right? Like the sequence is not monotonic.
No, I'm saying like I'm assuming the problem is false. So for every n, there is some t such that the inequality fails.
Or can you show
And
the
if the
problem?
inequality fails, this is what it is. So yeah, you have this, and now replace n with n plus t, and you have that a n plus t plus k is greater than a n plus t by c. And then you take you replace n with n plus t plus k by c and so on, n plus blah blah blah. And like this is just saying that this is greater than an by c cube, than an by c square. But we can actually just start with 1. It doesn't matter, but 1. Yeah, so you have that, we know this is at most m. And okay, in general, we can find some L such that AL greater than A1 by C to the K for all K. But this is at least 1 by C to the K, and this is at most m. So this is just saying that C to the K is at most m, which is, wait, what? C to the K is at least m, so at least 1 by m, whatever. Which is not true because C is less than 1. So as you take high enough powers, it's just going to go below 1 by n eventually. So this is not possible. Okay,
So you
except we did
only
assume this is C. Okay, why can we assume this is C? But shall we just strictly less than? No?
Yeah, wait, what?
Yeah, it is.
How did
Like,
E come?
oh, like
It
in
can't be
general,
approaching from both sides. Obviously.
this equals e to the fg or something.
Oh,
If this is tending to 1 and this
yeah.
is tending to 0. Or this is tending to infinity.
Yeah. And also, f is tending to 0, right? Or something?
F is, yeah, I mean, the whole thing is tending to 1.
Yeah, yeah. Okay.
And like the proof of this is just by taking log.
Yeah, makes sense.
Yeah, and okay, also the reason it's strictly less than is because this is like, you just, for some definition of interest, you just like deposit epsilon money and you like compound interest every like 1 by t years. So like obviously the maximum interest you will get when you compound continuously. That's when this is. Like it's
I
a
just
terrible.
want to know where did you learn this?
Learn what? Like, isn't this like in 10th grade? Compounding.
Yeah.
Uh, I know compound interest they teach, but what is this compound interest definition for this limit?
I
No, I
mean,
mean, like, e to the this thing is generally related to like infinite compound.
yeah, continuous compounding gives you e to the thing.
Why did I not know this? Okay.
It's a famous thing.
I
And
should
also
know.
in 12th, oh, you're not in 12th. You're excused from this.
Where do you
Like,
learn
otherwise you should know this.
in 12th grade? But where do
What?
you learn this in 12th grade?
I mean,
Where do
you
you
learn the
learn?
limit, no?
That's in 11th grade syllabus, by the way, limits.
Seriously? Okay.
Yeah, I think so.
Okay, I misremember. Okay, my sense of time is weird then. Okay, wait, Pranav, why do you not know the limits then?
I know limits, but I don't know this limit. 1 plus f to the power
It's
g
almost
is.
like definition of E.
Oh, now it makes much more sense. Okay.
Yeah, the first time I heard E was in compound interest.
You're learning things differently. I'm just doubting my skills now.
I mean, how, where else does E come up? Like, do you actually define E as 1 plus 1 by 2 factorial plus 1 by 3? Okay.
But the proof of that Taylor series is using this limit definition.
Oh, it is?
Like, okay, you can go from either way to either way, but I think the original thing was the limit, and then the Taylor series.
The only
was
reason I know it's equal to that is because Taylor series.
Yeah.
Not the other. Okay, anyway, I'll just go over the argument again. Uh, if we assume that the problem is false, in which case for every n, there is some t such that this inequality will hold. But on the other hand, by AMGM, we also have this. And together, this implies this inequality. And okay, we're calling this C. Or you can just pick any C less than the one that satisfies that. And okay, also you don't even need to know it's e to the minus epsilon. You know the limit tends to some constant. So since it's always less than 1, for all those finite values, you can just pick some C that's such that it satisfies. But okay, this exists. So we know that for every n, there is some t such that an by an plus t is less than c. And you replace n with n plus t and then with n plus t plus k and so on. You iterate this. And each time you get some a something is greater than a1 divided by c to the power big number. And you just get this inductively. But we have that c to the k must always be at least 1 by n, because the sequence is bounded between 1 and n. But this is impossible because c is less than 1 and k can be made arbitrarily large. Does that make sense? Okay. That's like 2 people, but it's fine. Let's assume that. Yes, Pranav, I see you said yes.
I mean, a fair few people unsacked.
Why some block letters 11? Original problem had this. I didn't change anything. Ask Taiwan people or whatever.
No, we do not do 11th problem right now. We want to do more problems.
Yeah, 11th problem looks hard.
Yeah.
Okay.
Even 12 looked hard at first. No, you just knew it in like 5 minutes, but
Like 12 didn't look that bad. Like either you have t of these numbers, you want it to be greater than t minus epsilon. It just looked like it would be detailed. Okay, 11 looks
people
14.
say 4.
Fourth.
4th also. I think. 4th was
What looks very nice, I will see that.
Oh yeah,
Okay.
let's just
Okay, if anyone, no, if no one has objections, let's just do problem 4. We'll wait for 30 seconds. Head solve? No. Yeah, but if no one objects, then. Yeah. These points are weird. Okay, we have 2 votes for 4. Let's just do it. It is also probably the coolest statement among all of these. Do a combo. Oh, we haven't done any combo yet. That's just sad.
Wait, why don't you do the Russia liars problem, the root n one?
Russia. Okay, yes, we'll do that next. Because we need to do some combo. Otherwise, like, I just do combo all the time. Nothing in PSS. It would be very unfortunate. Okay, but until then, we have a VC. We have an antipole dash. We have in center and we have an altitude. How is this true? What?
like these points are not random points, right? So like this angle
And they look
inequality
like
should be well
random
known, I'm
points.
assuming. Huh?
I mean, I've never seen any such result.
Yeah, that's what I'm saying. Why is it not well known? Like the points are not random, no?
Yeah, it is
Antipode.
pretty cool.
Yeah.
What is the antipode?
Unless it's like from the 1980s and it's just been. I feel like the thread, whatever it is, will just have someone linking to some old problem and saying this is not, because it's probably been seen before.
Also, maybe I'm not sure if introducing orthocenter is a good idea, because like orthocenter and that antibody reflections over midpoint of BC.
Yeah, makes sense.
What is the antipode?
Oh,
Antipode is
antipode.
diametrically opposite.
Yes, there's a circumcenter. It's the point diametrically opposite to A on the circumcircle of ABC. And also D and A dash are inverses around like root PC inversion, which is interesting.
What are was D and O?
D and A dash. BC goes to ABC.
Oh, okay.
Wait, that might be really good. Oh wait, no. No.
Yeah, but I don't know how you handle weird angles with inversion.
Yeah, also it doesn't have A in it. So yeah.
Maybe like just try BID as AID minus AIB. Then AIB becomes AIC and AID becomes A dash I.
Why is AIB equal to AIC? It's not. No? AIB is
Oh,
like 90 plus.
ACIA. ACIA.
ACI is C by 2. It's not equal to 90 plus C. Okay, but let's try.
No, AIB equals to ACIA, right?
AIB equals
Oh, AID. AID is
I-
what I meant.
Accenter? Huh? Can you
Yeah.
repeat?
You want to do AID minus AIB.
Okay. AID minus
Yeah.
AIB.
आए नहीं
Sorry.
कहाँ से नहीं आए
Don't want to be.
This is AID
Don't come back.
minus 90 minus C by 2.
पहले खाया था
But why is AID nice?
After inversion, it's like A dash IA.
IA? Oh, IA goes to IA. That is true. Oh, that's actually very nice because this is 90 degree. And like this is equal to this. So these angles are actually equal. And we know that angle AID is equal to AA dash IA. Does that help?
Wait, what's the other angle? BID goes, sorry, no, AIB goes to AIAB.
AIB goes to A dash IA. No, never. Wait, AIB goes to
ABIA, sorry.
ACI. ACI.
Huh? Oh yeah, ACIA. Yeah.
Huh. Okay, so we
That
know.
angle is known.
So this is BID. What is AID go to? A dash IA minus 90 minus C by 2. But A dash IA is a bit weird.
That's like ADIA. Yeah, that's not good.
Okay, we will do the dumbest thing possible. Let's suppose this is X. Then this is like 90 minus B by 2 minus X. And that's equal to this. And that's equal to this. I think. And we know this angle, it's equal to
Oh, we are done.
VR, A by 2 plus.
Like, no, we just know angle this, right? Angle IB, like let IB cap AD be T, then we know angle ITD.
Yes.
I mean, we are done anyway, right? Because we know
Yeah.
AID and we know AIP.
Yeah,
Yes,
like that is
this
just 90
adds
plus
to
T.
something. Like it has to work out. But what is it?
Like ITD is
ITT is
90 plus B by 2. Like TDB is 90, IBD is B by
I see,
2.
okay, 90 minus B plus B by 2. Yes. And this is angle ITD. And this was this.
So that is just X.
It's just X. Okay, yes. So we are done. Yeah.
Like probably explain solution once because
Sorry?
we did random stuff. Probably explain solution once in one go because we did random stuff.
Yeah, okay. Yes, also why is AID equal A dash IA? Because when you do root PC inversion, I and IA are swapped and D and A dash are swapped. So angle AID goes to angle A dash IA. So yeah, that's essentially what we did. We wrote angle BID as AID minus AIB. And or did we even do that?
We did that at the end, I think, right?
Yeah, okay. We just essentially let's not do right the angle, which is a nice way. Let's just show it the normal way. So if angle CIA dash is X, that's what we want to show angle BID is equal to. Then we know that angle A dash IA equals 90 minus B by 2 minus X, because angle CIIA is that 90 minus B by 2. And A dash IIA equals A dash IAI, because if this is midpoint of arc, then MI equals MI because of what is famously called fact 5. And because this is a 90-degree. But also because of inversion, AID and A dash IA are similar. So this angle also equals this angle. And because you know angle ITD and every other angle is nice, so you can actually find that angle BID equals X. Can you talk about Vieta jumping? If there is a problem involving Vieta jumping, I guess we can do that. But none of the ones I see seem to involve it.
I think he's just saying the physics of what was it, 1978 or something?
1988. But I've seen
Uh,
it. Like, I guess in the end we could do that if people want it.
Also, there's a non-inversive solution to this too.
Oh, what
Like,
is it?
let A dash I meet circumcircle at S.
Sharky Devil?
Yep.
Huh.
And then let AS meet ABC at, sorry, AS meet BC at T.
At?
T.
Huh.
So like TI is perpendicular to AI because like
Yes.
Radax or whatever. And you have that ATDI is cyclic because 90-degree.
Oh, 9. Ah, yes.
And then your angle chase is related.
Ah,
Oh, that is nice.
makes sense. Okay, that's actually quite nice.
Yeah.
But we did not use any lemmas. Okay, we
Okay,
used
we-
lemmas, but we didn't use Sharky Devil properties, which are like less
I
known
mean,
than-
this is, you don't use Sharky Devil here, do you? Just use the fact that ASI is 90.
Okay, fine.
So that's
Yes.
it.
Okay, fine.
It's better than using root
It's
BC
a better.
inversion.
Yeah, makes sense.
But like funny how that they are just two different configurations and then angles still relate.
Yeah, like A dash and I, it makes sense that you would introduce Sharky Devil. Although you don't need to know anything about Sharky Devil, I guess. But yeah, it is quite nice because extending this does create a 90-degree angle, so it makes things nicer. Okay, that's a nicer solution than what we have. Solution is solution. Okay, which
Is that
problem
solution?
next? Is Bash a solution? No,
You just said solution is a solution. What is this partial?
Bash does not count. We only
Wow.
do good things here.
Okay, do next do I'll just say a bad solution to that.
For your host, I can't do it. Okay,
Okay,
which
do the
problem next?
combo.
Do the combo. Oh yes. That is
Ninth,
There seem to
Is
be
it like,
multiple combos.
yeah,
ninth,
like one of the last two I've sent on OMC.
The 2 root n minus 3.
Yeah, that's pretty non-trivial.
Yeah, makes sense. Also, what is this? Wins if and only if n is odd. Wow.
That one is quite like,
Do the hunter and hare, it's 2.5 solution, 2.5 lengths.
It looks really hard though.
which one?
I mean, Mark BCC calls it tricky. So like,
Yeah, I am scared of it a bit.
Which problem?
Okay, let's just try this, I guess, because no one else voted for anything. I'll put it in the room. But if people hate the problem too much, we can just switch sides. Okay, does anyone hate this problem? Otherwise, we do.
I hate the problem.
Why did you suggest it? That's just evil. But no one else hates it. So I guess we will have to do it anyway. Okay. Truthful people always start. Who's definitely truthful is just someone who said the truth. He doesn't have to be like a non-liar.
What do you mean non-liar?
Like liars can also tell the truth.
Yeah.
So if we point to a liar who said the truth, that's also fine.
No,
I mean, there's no really way to differentiate between them, no? Otherwise, the problem doesn't really make sense.
like we have to tell who is definitely truthful. Liars are not definitely truthful.
Like my point is, you're given like one try. They just make one statement. So you can't differentiate between a
Yeah,
person who's a liar who's telling the truth and a truthful person,
Fine.
correct.
much like in life. Okay,
Where did that come from? Okay.
it's true. Okay. Wow. This is weird. Okay, so we have n people. I'm not actually going to do small cases because 2 root n minus 3 is probably not some ideal bound anyway. Okay, so let's just say like, oh, okay, we will introduce notation. To every guy, let's just assign a pair a comma b, where a is 0, 1 and b is 0, 1. So we'll say a is 0 if he spoke, if he is truthful. Oh wait, that's just so annoying. So even if you're lying and telling the truth, you shall count as a liar.
No, like,
Like if the guy behind you says he's a liar, then he would be truthful.
if he is a liar, but he said the truth, then yeah, he's a liar anyway.
Oh, how do you do this? It's like,
But like, you're given that there are only like few liars.
yeah. But the problem is these liars can just decide like, let me be nice. What can we do? 2 root n. Is it like you'll take number of pairs of love? Okay, whatever. So we'll color.
Because of root n, it probably seems like some PHP to me. Like I don't know on what, but just because of root n. That
Interesting.
just sounds very weird. But yeah.
Yeah, I just want to like get some
Sometimes.
structure on the problem before trying anything. Okay, so let's just assume the
Also, I
yellow
think
guy.
like some amount of base case might be decent, although like you're right, 2 root n is bad, but like just to get a
Yeah, makes sense. Okay, let's try n equals 3. So There's just so many cases. You don't really want to do this. Okay, let's just look at general case, and if we just flail around doing nothing, we'll move on to try and base cases. So yellow people are the guys who are actually the liars. So everyone else tells the truth, although of course we don't know which ones are the ones marked yellow. So if there is a situation where we can't point to someone who's truthful, it means that for every single person you pick, there is some configuration of picking liars, which is consistent such that this guy is a liar. That made no sense, but like, if I want to claim that this guy is truthful, then there must be some configuration of yellow such that, like, say instead of these three, like this, and this were yellow, such that this was still a valid configuration. Okay, so what can we say about such things? You'll have, okay, I'll just draw more dots because in general you will have more dots. So there are going to be pretty long lines of truths for sure. I mean, of saying, yes, he is truthful. I'll say Y if the person says it's truthful, and N if not. So all of these people say yes for sure. They don't really have a choice. And okay, in fact, these people will say no. And these people, okay, let me also just pick two liars next to each other because that's also a possibility. And okay, so yes, 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 no. And now every liar has a choice to say yes or to say no. So in general, there's going to be like at least root n by 2 such chains of yeses and no's or something. So in general, if you were just told the responses and you saw a long chain of yeses, you would be tempted to point to one of them and claim that they are truthful. But the problem is it might just be someone pretending to tell the truth.
What if, like, let's say you have a long chain? Okay, not long, but long. I just mean not a long enough chain, but like,
Like,
what if
there will
all
be
these,
some reasonably long chain.
yeah, but like, what if all these four are liars here?
All these four are liars. Yeah, the point is there's very few of them. So ideally they shouldn't affect it so much. Like in this case, if they all lied, you would have what?
Another very long chain of yeses.
Yeah, I want to pick something in the middle of the long chain of yeses.
That
So
makes
this guy
sense.
says yes, this guy says no, no, no. This is one such situation. Wait, actually, if I just see some chain of a bunch of people saying yes, and I point to some guy, let's assume 7 of them, and I point to this guy and claim that he is truthful. So the only case I'm wrong is if he is actually a liar. But in that case, this must mean that this guy is also a liar. And basically everyone to his left is also a liar. Actually, instead of picking the middle guy, maybe we want to pick to the So
No, even if you pick the middle guy, the next guy should also be a liar, right?
the next guy should be a liar. Wait, so
No,
like say I'm picking this guy and claiming he is the truthful guy. But if he is a liar, then so is everyone before him. Right? And so on.
Wait, like this person, yes means the next person is truthful, right?
the liar can choose to be truthful. So
Yeah.
if the
You don't know
if
anything
I
about the next
say
No. We want to pick a person who is saying truth in that turn, right? Even if
Yeah,
he's a
so I'm pointing to this guy and claiming he is truthful.
no, we want to pick a person who is like a good person in general, not person who is saying the truth in that term.
Yeah.
Oh, then fine. I thought you confused me in the beginning. I told that.
Yeah, I was confused in the beginning too.
Yeah.
Okay, so we know that in any chain of yeses, either the endpoint is a truthful guy or the entire chain is of liars. So if there was a chain of yeses which had like length at least 2 root n minus 2, we would be done. But there is no reason to believe that there should be such a chain. But maybe there should. Okay, so if we don't have a long chain, then let's just break this up into chains of yeses, something like this. And we know anything has length at most 2 root n minus 2. Like, I doubt we will actually be the exact thing. But so, okay, actually, let's just fix some number L given n, and we'll look for a chain of length at least L. Or we'll actually just pick the chain of maximal length. So let's say this is our chain of maximal length, right? Sorry. Yeah. Then let's say this chain has length L. And we claim that picking the rightmost person will work in the maximal chain of yeses. So if not, then L of these liars are used up here already. So there is at most what 2 root n minus 3 minus L liars left among the remaining. But a break in the chain occurs only if there is such a liar. So we know that there is at least one liar in every of these gaps. So if there are like, in this case, let's say there are C chains, right? Then actually, we know that there is these many gaps. So actually, at most 2 root n minus 3 minus L chains. But also every chain has length at most L. So the total number of people is at most 2 root n minus 3 minus L times L plus just 2 root 3 minus n minus L.
Yeah, now this is just computation type.
Yeah, okay. You just pick L to be root n or something?
Yeah.
Okay,
That
yeah.
kind.
Okay, this is 2 root n minus 3 minus L times L plus 1. But number of people is n. And I guess this inequality will just work out. Okay, fine. That's a nice problem, though. Initially, I was just tempted to like take cases and how it'll look. But you're looking at chains of yeses kind of makes sense.
And it feels intuitive also, I guess. Like,
Yeah.
too many
Yeah.
yeses, like, yeah.
Essentially, like you just pick a long chain, and the only way it fails is if all of them are liars. But you have too few liars everywhere else to break the chains. So there must be a bigger chain somewhere. Okay. This was an actually nice
Why
problem.
do you hate the problem?
Yeah, this is a nice problem.
What? I suggested the problem. I was just joking.
Okay,
Oh.
good. Okay, did that make sense to everyone, or should I repeat the thing?
You didn't say make sense to someone.
Sorry.
Bad joke. No. Sorry. Just ignore.
Okay.
Don't try to make sense on such things.
I see.
Can you explain your solution once?
Yeah, okay. So I'll explain the motivation later. First, just the solution. So we're given a bunch of responses and responses, each of which are yes or no. So we'll break these into chains of yeses. The chains of yeses are these blue lines here. And the dots in the middle are the no's. So we're going to pick the chain with the most number of yeses. and pick the rightmost guy over there, and we claim that he must be truthful. So the reason is, let's say there are L people or L elements in this longest chain. For the only way the rightmost guy is a liar is if everyone else in this chain is also a liar. Because if the previous guy said yes, then he must have lied, and so on until for the entire chain, right? But also, we know that in every gap between these chains of yeses, there must be at least one liar. Because you can check if they were just truthful people, then you would just continue the chain. You would not actually break. Because the only way you can create a no is if either you are lying or the guy in front of you is lying. So because there are L liars, we know that among the rest of the people, there are at most 2 root n minus 3 minus L liars. Like, it's a weird expression, but it's what it is what it is. So we also, because there are at most these many breaks, we know that there are in fact at most these many chains also. But by maximality, every chain has at most L people. So we know the number of people is at most, this is number of chains times L, because each one has at most L people plus those breaking people, which is actually, it might be twice of this, but same thing, like details. And you get this expression, which by AMGM or something is going to be strictly less than N, because the problem has to work out. And so this is a contradiction because N is less than N. Does that
Yeah,
make
makes
sense?
sense.
Okay, nice. This is actually a nice problem. See, this is why people should do combo. Combo is so good.
Or you can
Okay.
say this is why people should do math.
I mean, if you are doing math, if you aren't doing math, it's unlikely you're attending the session anyway.
Some people do CP also, and then they attend for combo.
Yes, so combo is even better that way.
Okay.
What is against? Why are you against my combo propaganda? Anti now. Okay.
Get a bash propaganda. I'll the first person to join you.
Oh no.
This is my class, Pranav. You don't get to say stuff about Bash here.
Sorry.
Okay, anti or algebra, people say.
Anti.
Okay, so the anti I see is problem 10. Problem
Yeah, do
10. Is that it? Is that the only anti left?
No, wait, it's like another.
Oh, there's also 3. Yeah,
I mean,
okay. Problem 3 or 10. Vote, people. Each of them has 1 vote currently. Oh, okay.
3 looks fine.
Never mind. I see how to do problem 3. It is a special case of a problem I've done recently. Okay, so problem 10 is in fact the only one that remains, unfortunately. But problem 3 is actually worth doing in general. It is a very nice problem. Assuming there's actually no explicit construction, because the intended solution is, it's great. It's a very scam problem, but it is great. What is this? Proof that there is
Is this like some China TST problem?
Yes, apparently it is China TST. This one's not fine.
I just don't want to see the problem. All the best doing it.
Okay, it's essentially saying that proof that for every positive integer k, there is some n such that for any n greater than n factorial plus 1 has no prime factors among n plus 1, n plus 2 until n plus k. I think that's what it is saying, essentially.
Yn plus k, n plus an, right?
Yeah, I'm saying you can set a n equal k for big enough such n.
I see.
because that's essentially what the thing is saying. It needs to be strictly increasing. So like, because of Wilson's theorem, you're told that n plus 1 is not prime. So, you know, an can never be equal to 1. So you can always take an equals 1. That's always valid. But it's saying that you're not allowed to just stay at 1 forever. You have to make the sequence unbounded. So it's saying eventually n plus 2 also cannot divide n factorial plus 1. That's what it is saying. Okay, it's an interesting problem. So I guess we can just start with why can't n plus 2 divide n factorial plus 1? N plus 2, we're assuming is a prime. This looks actually very reasonable. I don't see why it's not possible. And when n plus 1 is prime, it always divides, in fact. Like -2 -3.
If we take n plus 2 to be prime, isn't RHS like 2 mod p or whatever?
Wait, why?
Because like n factorial is n plus 1 factorial by n plus 1,
Huh.
which
Oh,
is
right.
minus 1 by, yeah.
Yeah, okay, that makes so much sense. Okay, in general, if n plus k you want to, we know n plus k is going to divide n plus k minus 1 factorial plus 1 by Wilson's theorem if this is prime. But we also know are told it divides n factorial plus 1. So this implies n plus k divides, what is it? N plus 1. N plus 2 until n plus k minus
ಯಾವ್ದ್ರಲ್ಲಿ ಬಂದ
which sounds reasonable like that. Oh, I see. But you can write this as n plus k divides -1 -2 all the way until minus of k minus 1 minus. But this is just some fixed quantity. So if we just pick n such that mod n plus k is greater than k factorial, just pick n greater than k factorial minus k, then we are done.
Don't
Great.
tell me you're done with the problem.
Hmm?
You're done with the problem?
I think so. No?
I was digesting the problem. Like, what? Okay.
Like, it is a bit weirdly written. It's essentially just asking you to show this. For any positive integer k that I fix, you can find such an n, such that for like all sufficiently large numbers, n factorial plus 1 has no prime factors among these, if n plus 1 is not prime.
Okay.
And the way we did it is if, let's assume n plus k divides this thing. But by Wilson's theorem, we also know it's going to divide n plus k minus 1 factorial plus 1.
Yeah.
So like if you multiply this by n plus k minus 1 factorial by factorial, we get that n plus k also divides this thing, right?
Why do you multiply it back?
Like, okay, this is actually saying like n factorial is congruent to n factorial times n plus 1
Yeah.
stuff. And so this is congruent to 1 is the point.
Okay. Oh.
But this is just very close to n plus k. You can actually just write this as -1 -2 till minus k minus 1.
And which is fixed.
Yeah. So you just pick n greater than k factorial minus k.
Oh, it's nice that how you can just even pick your n. Like you have a bound n.
Yeah. But yeah, the problem doesn't ask for any bound. It just says show that there exists. Okay, nice. Does anyone have any questions? Would you like me to go over the proof or how it's solved?
How to be so fast that you just solve China TST? Just like
I mean, this was Kritar's idea, that's why.
Oh.
Wait, what was my idea?
Like you said, Wilson, I didn't
Oh.
realize. Like that is essentially the idea because it divides this.
Right.
Like these are just very too close in some sense,
Huh?
Yeah.
which also in some sense should remind you of Lamar P4 and stems P1.
Yeah, bad memories. Let's just move on.
Bad memories.
Alright. Okay, so which problem next? Someone said P9. It is the largest.
Have you not done P9 when we were making the IUQM mock?
Like I think few people didn't. I think, but
Yeah,
it doesn't look like
9% families.
the most interesting problem.
Like,
Like,
IUQM walk.
You were also there. For
like
I was
I can
no
just
way.
draw the cycles and check. But okay, let's look at. Is there any other problem people would like to do apart from P9?
13th, A plus B by 4.
Oh wait, is P9 intended to be 25 because you can pick night, all white knights again? Like the revenge Lamar problem. Because then no two knights will attack each other.
I don't think it's that bad.
I think it is
No,
a
but
valid
we'll assume
solution.
it is then and we'll move on.
Yeah.
Yeah, also technically, like by PHP, you have to end up placing like half of the knights of the same color, so they don't actually attack each other. So the problem is actually a lot harder than it seems. But I assume it's not intended, and let's not do. Okay, any other suggestions, people?
A plus B by 4. 13th problem.
Plus
Yeah.
1. That looks bad.
Yeah,
Wait,
that's why I
also
wanted to
Atul,
do it.
that doesn't make the problem harder, no? Doesn't that just make it easier? Like you take
No,
all
wait.
on one color as one thing, all on. Okay, no, maybe no. You have like 3, 5, 8, 10, 13. Yeah, 13 of whites and 12 of black. So just put 13 white knights on white squares and.
But then white knights and black knights attack each other, so that doesn't really.
Oh, wait, we want. Oh, yeah, yeah.
Genius logic.
Yeah, then it's a lot harder.
Yeah. Like assume it's not that hard, it's just 5 by 5, you can check. But
I mean, you can probably just bash it out.
yes.
I mean, you'll just have a 25 cycle or something, I think. No.
Uh,
Some weird graph.
it is a weird graph, yeah. Solve problem number 10 plus 54. Is that 54?
It's 52, right?
13.
54.
So no, that's not. Okay, does anyone want to do anything except 13?
13.
The
I
9-point
would like
circle.
the 0.0001.
I'm pretty sure it's a scam. Like
I mean, it's probably a scam, but
I
do
mean,
you
you
want
can
to
just
do-
prove epsilon probably, but yeah.
Yes, but
kind of
2015, I feel like 2 to the power 2015, something is going to be. Like, I do not like this problem.
9-point circle.
9
oh
points.
yeah, let's do 9-point circle.
Oh yeah, this looked like a very cool street. Okay, 9-point circle it
It
is.
feels like it should be the Ponsonby point or something.
I have no idea what you're talking
Oh, wait, I have
about.
done
Isn't
this.
Ponsonby point defined for like 4 points that don't form an orthocentric system or something?
Right. I confused the definitions. Never mind. Let's just continue.
I just wanted to say Ponsonby point.
Did Ravi suggest this? Because I feel like Ravi has posted this on notice or something.
Yeah, Ravi suggested this.
Yeah, I think I've seen this.
We are fixing the circle and we're looking for 9-point circle. Okay, so the nice thing is that this will always go through midpoint of BC. So it does have some fixed thing. Okay, if A was midpoint of this arc, then the circle is just
In circle.
the one tangent to BC and with radius with R by 2. Oh wait, also in this case, if you pick it to be the other midpoint of arc, then also it's just that, no?
Yeah.
So it's the same thing reflected across BC.
तो उसका ऊपर का चिपका हुआ दीवार अलग होगा, अंदर का माल तो वही है.
Sorry?
So that was just by mistake.
Okay. So this circle is probably also symmetric with respect to BC. So circle has center on BC. Oh, does a circle just have center M? Is it just like some circle that looks like this?
Yeah, I was also guessing that.
Oh, but this is just true. Okay, that's nice. Because
Are you
like
kidding?
M is fixed. Yeah, like M is fixed and radius of circle is fixed. No?
Huh?
So as it varies, the distance from M and the farthest point equals R.
Huh?
Yeah, so the yellow circle is a circle with center M and radius R. So it's always tangent.
Why is this always tangent?
And you have two circles. One is like here,
Oh,
radius.
oh, right, fine. Okay, nice. But how do you show that it's tangent? It's tangent, yes. It's
Like farthest point because
yeah,
diameter.
yeah.
This is like midpoint of AH or something.
Genius.
Okay. Okay, that's actually a nice statement. So
Yeah.
it wasn't that hard, but it was a nice statement.
Wait, what did it do?
The circle is the circle with center M and radius equal to circumcircle. It's like 9-point circle goes through M and has diameter equal to the circumcircle radius. So that's just true in general. Like you have two circles, one has radius equal to the diameter of the other and goes through center, then it is tangent.
Yeah.
Okay. Which problem next? I'm just avoiding the second page because it has that problem.
13.
Let's do the ones we sent in thread. Okay, more like I sent, but okay.
Yeah, so there are a bunch of problems sent by
Let's do
Krita.
16.
Hunter and Hare.
There is a hunter and hare indeed.
Let's do 16.
What is 16?
Okay, probably not. It is not 9-point center of BIC. I don't want to think about that.
And like, I'm scared of the centroid
Centered of what?
of BIC.
Oh. Oh, 9-point center you can just compute, right? It's like the center of midpoint of arc, and I think ortho center of BIC is also nice.
What?
What is
I mean,
ortho
ortho center is nice, yes.
And
Oh,
yeah,
that way.
9-point center is also nice, no?
I see. That's interesting. Wait, 9-point center is midpoint of OH, right? Wait, wouldn't that just be the center of circle or something?
Uh,
It is, no?
no.
Like ortho, oh, never mind. Yeah, it is not that obvious. It does
But-
look hard though.
Probably like I'm guessing you relate centroid and the 9-point center by some homothety.
Yeah,
So
like
it's
it likes
not that
Euler
hard.
lines.
Yeah.
Okay,
You want to do?
let's look at some other problems because this looks pretty hard.
Sure.
And also we just did geo, so preferably non-geo now,
Yeah, 13 is non-zero, but okay, let's just pick from the thread.
not 13. What's on the thread? There is it's okay, so we can do NT or combo. Choose. N to the 3PQ minus N. Yes, I have done. Okay, people seem to want combo. Good people.
NT.
NT.
Combo.
Okay, combo it is.
Also,
was
the other
too-
combo I sent is also decent, but like that
Oh, I
you
see a-
finish.
I see
No
a
time.
number theory combo game. Let's do it.
Oh, that's good.
Ingrid and Eric. Okay, this is definitely not it. Okay, so
Also, Atul, maybe just pick a problem which is not that hard because like it's already about 8:30.
oh wait, we're almost done. One more. Okay. After this, we'll just do like one more problem or something. If this gets over quickly.
Yeah.
One of the problems. Let's see. Let's just do small kids, I guess. So if p equals 3, you only have like 1 and 2. Let's just call them Alice and Bob. Because I can write A and B there. In the write-up, you'll obviously write Ingrid and Eric.
Oh, this doesn't look that hard, I guess.
That's it.
Because like once, like let's say the number 1 come, then you can just start from the beginning in some.
Oh wait, does A just when? He first removes 1. Every
Yeah,
time
and
you
then whatever
remove
we
like
pick,
A,
we
you
just
just
pick
remove the
inverse.
inverse. Okay, fine.
Yeah, wait,
So A just gets too much points. Okay. A gets P plus 1 by 2 points and wins.
wait, A gets all the points, right? What do you mean P plus 1 by 2?
Yeah, look, he
Like,
plays P
whatever.
plus 1 by 2 times.
Yeah.
Or P minus
What
1
if you
by
choose -1 though?
Oh, right.
Like P -1, you have to be careful, right? Because I can't choose P -1 again.
2. Yes, okay, it's not that obvious.
Maybe take P equals to 5 case.
X equals 5. Wait, I think the second player wins.
Okay, like what if we pick
Yeah,
4
second player wins. So like he pairs you just pair X with 1 by X if X is not equal to 1 or -1. And you pair 1 with -1. So every time player A picks one of these, player B picks the other one. And this way he always ensures that after his move, the product is equal to 1.
How? Because like let's say I pick let's say you pick 1, you're the first player, and I
I
pick
pick
-1.
-1. Yeah.
So now it's not 1, right? So like I'm not getting any point.
Yeah, it's a draw.
Yeah,
Not even a
nobody
draw.
ever
I'm
gets
in
it.
fact losing
-1.
point.
Yeah,
You're getting a
A
point.
wins.
I see. So
Yeah,
we
A
would
wins.
like -1.
Okay, so hmm.
Oh, okay. I see the strategy, I think. So let's say I pick first one, and if player B picks something X, which is not -1, then you can pick 1 by X and you can get a point, right?
You get a point, yes.
Yeah. And let's say I pick -X, and then I think you can just 1 second.
Like let's say player B picks -1, what do you do?
Yeah. So I pick
Oh, okay. What about you pair -1 with 1 and all, but when the first time you try to pair with like inverse ka negative,
yeah,
the
that's
first
what
time
Wait, the
something like
initial
that.
product is -1, it's not 1. Oh, okay, that's even better.
Oh, okay, that's much better.
Yeah.
Wait, so doesn't Alice like essentially always win? Because like if he chooses -1 first,
Hmm.
and now whatever I choose, you just pick the inverse.
But what if you choose 1? That's the problem.
Uh, okay, that's fair.
Wait, no. We started with -1.
Yeah, and your
Now
opponent picks
Alice,
1.
if Alice picks 1, then we pick -1,
Yeah, but
and then we copy.
Wait, can't we force a draw in that case? Like you play -1, I play 1, and then we just put inverses. We get equal points, right?
wait,
Yeah,
how do
maybe you want to
inverses get
prove
equal
both
points?
people can force a draw.
Maybe you can do more than a draw. Oh, are you saying both people can ensure it? In that case, okay, so what is the strategy for, let's say, Alice? What is Alice picking first?
Like, okay, let's take p equals to 7.
Okay.
Then I pick 1. Like the first person, Alice and Bob. Alice picks 1. Alice has 1 point. Bob picks like
No,
Bob
Alice
picks,
picks 1, Alice gets 0 points, is the point.
why?
The initial product is -1, it is not 1.
It's 1, right? Like what?
What is Wilson's theorem state?
No. The product of the crossed out numbers you are considering.
What?
What?
Bro, like
Okay, that is very unfortunate.
geniuses. Yes.
Okay, that's very sad actually.
Yeah. So
Oh, okay, that
Alice,
changes a lot of things.
very people doing it with the non-crossed out numbers till
Yes.
Yeah.
It's almost the same thing because you just wanted, we were looking for it to make it -1.
now. Sure. So Alice picks 1. Alice has 1 point.
Yeah,
Now
Bob picks
if Bob
-1.
picks anything, yeah, Bob picks -1. And now I pick,
You pick?
let's say I pick 2.
Yeah.
Then Bob can pick 3 and get a point. And now Bob will keep on getting points.
Yeah.
So, and whatever I pick, Bob can just do that. So Bob wins.
No, the issue is basically you want the negative of
the-
the modular inverse to be a different number. That's the
Yeah,
only
but
thing.
you can have x squared plus 1 equals 0. No,
Yeah,
when if p is 1
exactly.
mod 4.
Oh,
Okay,
so
if p is
essentially
3
whenever
mod 4, b wins.
oh, the so basically we want like, oh, so if no QR exists, then we are done, right?
No
So we are
QR.
done for quadratic. It's not, no. No, man.
Every prime has quadratic reciprocities.
Yes.
If p is 3 mod 4, b wins. Yay. Now what if p is 1 mod 4 is the question.
Also, wait, is it that easy to finish? Because you can't exactly pair everything up because you've used a -1 by x, which wasn't exactly a pair. So if now you pick
Wait,
like
why can't you
minus
pair
x.
everything up? Like you just pair x with -1 by x. And this is valid pairing.
Oh, no, but then you don't keep getting points, right? You only get points like alternate time or something.
Yeah, but that's good enough. You win in.
Does Oh yeah, so the other guy doesn't get any points.
Oh, but it's possible the other guy begins with something. The other guy gets like 1 point at most every time. No? Like when he picks x to be 1 or -1, he gets like at most 2 points overall.
Yeah.
And but this guy gets p -1 by 2 points, which
Yeah,
for p at least 5. Okay, for p at least 7 because p is 3 mod 4, he wins. But what if p is 1 mod 4 is the question?
Or maybe it's like a, I don't know.
Yeah, maybe. I still want to pair x with -1 by x except the self-pairing thing. X squared plus equals -1.
So if a plays such an x, you can't really do much.
Oh wait, you can still pair x with -1 by x, and you just pair I with -I. That's still fine, no? Because in this case, the product is it's 1 in this case, and it's -1 in all other cases. So you get like at least p minus 3 over 2 points. And the other guy gets at most 4 points. So if p is at least 11, you're fine. So we just need to check p equals 3 and 5 by hand.
That's fine.
Yeah, but that can be done. I think p equals 3, the first player actually wins. P equals 5, let's just check quickly. Let's say I pick 1. and you pick say 4. Yeah, you can't really do anything. The first player wins anyway. Again. Okay. Because the first player just picks 1, and if the second player picks 2, then he just picks 3 and wins because he got 2 points. But if the second player picked 4, then he just picks 3 and then 2, and then he got 1 point. No one else ever did. Does that make sense?
Yep.
Okay, nice. Also, this should be p minus 5 over 2. But it's still fine because 13. Yeah, this is a nice problem. Assuming you just don't fake solve saying pick inverse, haha, we are done. Because -1 exists, unfortunately.
Yeah.
But yeah, otherwise it is nice. Okay, the class did begin a bit late, so like, do we do another problem or end?
If you do the problem I send, that'll finish very fast. Like if you're looking for
Which is the
Krishna sent a
problem?
problem. Do that.
the last OMC.
Yeah, do the Krishna problem.
The last OMC,
No. Do the Krishna problem.
the Krishna.
Okay, yeah, let's do.
Oh
In
gosh.
triangle ABC, let KH.
Yeah. Who am I here? Conic.
Okay, Atul, I can do that by Barry. You
No,
cannot.
Pranav, we didn't ask you.
This
You
is-
probably just want to show Pascal holds or something for some special thing.
What lines of Simidian point are nice?
We will
What
figure
Pascal will you do?
out.
I feel you can do that thing. Hyperbola stuff.
Also, wait, what did you get answers for this problem?
I think for P at least 11, second player wins.
Yeah.
And so we didn't check 7. But 3 and 5 first player wins, 7 we have to check, but it's something.
Yeah, 7 is a draw.
Oh, 7 is a draw. Okay, fine. Makes sense. Okay, so Rochelle, you were saying pick the
Krishna problem.
Annabelle and Brandon.
Sad.
I mean, the Krishna problem looks hard.
Like with Barry, it's not hard.
Like,
See, Atul, at some points, bashing is good. I'm not saying always, but you have to agree. It's
we have
something-
limited time. Let's not argue. Let's
Okay.
just do this.
I feel like I'm gonna get blocked after this lecture. But yeah, let's do the Rochelle's problem.
Okay, Pranav has done that, I think.
Which one?
Frog.
Oh, you did this with me only, right?
Yeah, like
I did not do this with anyone. Oh, you mean Rochelle? Okay.
This
His
is good.
problem looks interesting.
This is good.
Mhm.
the funny thing is I read as instead of plain, I read it as one dimensional, and the problem became much harder, even though that's a special case.
And on phone, he's just like ranting, why is this problem so hard? And then he realized, oh shit, I read it wrong.
Also, like the proof thing, maybe I should have removed.
Oh, you should have just asked when you will.
Yeah.
It is interesting that because there's only one other problem that's like this, and then that you look at maximal matching. But I don't see
Oh.
what matching you consider here.
Okay.
What? That's the
Nothing.
Anna and Vito playing on N Islands. Is matching relevant here? No, because there's like, no one. Who starts? So Alice wins.
Okay, yeah, it's actually not easy. We spent like good 15 minutes solving this.
15 minutes.
No, that was for us, not for you.
We'll end the class at 17 minutes.
Yeah.
What do you do? Like, I'm convinced you need to take some random matching somehow. But like, I have no idea. So we're going to like completely reverse engineer the solution. Let's pretend there was a matching somehow. Then what property must the matching satisfy for it to work? Let's say n is even. Then Bob just plays on the corresponding thing. Oh, I see. So for n even, you just pick like n pairwise not intersecting segments, which you can do. And every time, let's say Alice plays here, then Bob plays in the corresponding pair. And every time Alice moves, Bob also moves.
Wait, are you sure about distances?
About?
Distances, like you need to make sure that the cross distance is more than the.
Ah, I see. Okay, that's annoying. Wait, so if we have A, B, C, D, the only way you can move from D to C is if AC less than AD. But you're claiming I can't move here, so you're also saying that AC is less than BC. Okay, but that means nothing. This won't work.
I mean, you can pick BC and also
I can pick what?
you can pick BC, so you have a lot of freedom.
Yeah, I want to create these pairs, but I'm not sure how. Okay, so what is the problematic case I just need to avoid? The problem is if AC is less than AD, but BC is greater than AC. So if AC is less than AD and BC. Okay. So you kind of want to create pairs such that any distance is less than the cross distance in some sense. Okay, so let's say Alice played on some point, and then Bob plays on the point closest to it. So, and Bob creates an edge here. And now if Alice moves somewhere else, then Bob moves to the point closest to that. Does that? No. Okay, but the problem is essentially to find such pair. There's probably some just extremal argument to claim this directly.
Yeah, extremal is like
Wait,
Uh,
can't you just do this? Like pick a random vertex, pair it with the thing closest. Pick another vertex, pair it with the thing closest not chosen.
no,
And
but
so on.
like, okay, in the example you were doing, like, let's say, Alice plays at A and you play at B. Then
I am
he
playing at
moves it.
B.
Okay. So now you try to move at, let's say, B, but BD was the closest already, like
BD
something like
can't
that.
be the closest. Like the way I chose was first
But
this closest. Then
no. So A is like the closest to D, right? But um,
yeah.
there can be something closer to A. So
Yeah,
if
that's fine. Like my point is I can pick n segments, like I'm calling them A1, B1, A2, B2, A3, B3, and so on until AK, BK, where K is equal to n by 2. This is the case when n is even.
Hmm,
And this satisfies the property that AI, BJ cannot be less than both AI, BI and AJ, BJ.
why can we pick this?
Because that's how we picked. So pick random vertex as A1, pick closest thing to it as B1.
Okay.
Next, pick A2 randomly and then pick B2 closest to that. Or okay, that may not work. I see.
Yeah, it's almost the same, but little bit
Almost the same, but
like what I did is little bit different.
uh, and I assume like the strategy for odd will be the same. Just Annabelle
Yeah.
just pairs everything except one and then plays here. And when Bob plays, moves to there somehow. But how do you ensure this?
Okay, I feel like reverse engineering made it a lot harder.
Oh no. Wait, the pairing you have satisfies this, right?
Yeah,
Okay.
it actually satisfies something much stronger. But yeah.
Okay. Do you just like order all segments in order and then first pair among the remaining longest segment, this, longest, this, and this?
Longest.
Huh. Or shortest, shortest. Shouldn't make a difference, I think.
Yeah, I'm not sure how longest works, but what I did was shortest.
Ah. Yeah, I think longest will also work because uh, yeah, you're right. Shortest instead. Okay. And then shortest just works. And for the odd case, you pick the shortest distance and then some second shortest like this, and then do the remaining pairing. And you play here and when Bob plays. Or uh, okay. The case when it's odd is going to be a bit different. Okay, how do you do odd?
I mean, isn't it like the same?
Like you do the pairing, but there's one remaining.
Like, yeah, it does depend on how exactly. Well, how exactly did you choose these A1, B1? Like shortest across
Shortest
everything, then
segment, first shortest, then remove those two remaining shortest and so on.
yeah, and now you have one extra point which is left.
Yeah,
So you play there, and
yes.
then wherever B plays, you play at its.
I see. Okay, it is short. Okay, makes sense.
And yeah,
Yeah.
like I motivated this because like if there is the shortest segment, you can't play at either one of them.
So you want the other guy to play there and then you pair it up.
Yeah, okay,
And
that
so
makes
those
sense.
2 points are essentially like rejected, and now you can keep going.
I see. And then if you pick kind of the second shortest thing, this one is already banned. So in a way that also has only one
Exactly.
choice. Okay. Yeah, this reverse engineering was unnecessary.
But like
But
that's really insane to like, because like you see the entire idea and then you're like, okay,
yeah,
but
like the reason is it's just n points. They can be in any random position, and all that matters is parity of n, which is
yeah.
pretty surprising. And like the only other case I've seen such a result is in this.
The weird thing is like I write like 1D and like I had no idea for like a solid 45 minutes I tried it. And like I was just stuck.
Yeah, 1D you're also tempted to like move closer, and but
Exactly.
you can also move across, and it's weird.
Yeah. It's
Yeah,
like,
and you're not really
and
thinking
like
of
the shortest
distances.
thing doesn't really make sense there because like
Yeah, you
the
wouldn't.
shortest thing in the remaining ones might actually be like jumping across two already
Yeah,
fixed.
yeah. 1D is just making it harder to think of unintentionally. Okay, yeah. It's like 8:55. We should probably end now.
You're done, right?
Yeah.
Yeah, we did a lot of problems. That was nice. Thanks for the class. It was like pretty awesome, I guess.
It was
You're still recording?
Good point. I'll stop.
Yeah.